What we're looking at today is applications of linear systems. So we're going to look at word problems of when you need to use graphing, substitution, and elimination to solve systems of equations. So we're looking at applications of systems of equations. Now remember, as a quick review, we've already solved systems of equations by graphing. Okay? And when do I use graphing? This will help you to know when you use graphing, when to use substitution, and when to use elimination. Okay? So the first types of problems we're going to look at today, we're going to use graphing to solve, or substitution to solve. So, when to use this is when you want a visual display of the equations, or when you want to estimate a solution like this. See, I want to see where is that point right there, and that point where they cross is the solution to a system of equations by graphing. Now, when do I use substitution to solve problems? Okay? When one equation is already solved for one of the variables, or when it's easy to solve an equation for one of the variables, like this. If I had this system of equations, y is equal to 3x plus 4, and 4x minus 3y is equal to 15. That's easy to solve by substitution because y is equal to 3x plus 4. It's already solved for y. I just plug that value into y into the other equation. Then it's easy to solve for it because it's in terms of one variable. Now sometimes I use elimination to solve problems. When do you use elimination to solve these? This is when the coefficients of one of the variables are the same numbers or they're opposites. So it's the same number, different signs, like this. If I had something like 4x plus 3y is equal to 10, and then negative 4x plus 4y is equal to 20. My coefficients are the same numbers, but different signs. So that means they're either exactly the same in every way, or they're opposites. A positive and a negative are opposites. That's what that's saying. So it's real easy to add them together, and if I added these two together, it would eliminate the x's, and you'd just have this in terms of y. So you'd have like that. 7 times what's 30? And so y would be equal to 37. So that's a quick review of those three methods. Are we good with that? Okay, now I need to explain to you a quick concept before we get started. And this is talked about the break-even point. This is talking about the break-even point. So we're going to pretend like I'm going to sell that pen. Okay, so I'm selling that pen. And I say, hey, I need you to produce these pens for me. And this guy says, yeah, I'll produce those pens for you, but it's going to cost you $200 as a setup fee, and then I'm going to charge you $1 per pen. See, that's my costs. That is a cost function. So what does this one pen cost me? It cost me $200 plus another $1 per pen. So it cost me $201 for one pen. If I got 0 pens made, it cost me $200. If I make 2 pens, it's $200 for the setup fee plus $1 for each pen, which is $202. Do you understand? So what is the cost to produce this pen right here that I'm writing with? It's $1 per pen, so it's $1 times however many pens that I make plus the $200 setup fee. That is a function rule that's graphed kind of like here. That's called my expenses, or another word for that is my cost function. Notice how this graph would cross the y-intercept at a value, and the value that it crosses the y-intercept is my initial cost. Do y'all follow that? All right, and then it's going up. My cost is increasing per each number of pen that I make. If I make 1 pen, it's 201. 2 pens, 202, 203, 204. And so it's steadily increasing as I produce more pens. And it's going up forever. If I make 5 million pens, what's the cost? 5 million plus 200 would be $5,200,000. Okay, so how do I start making money? I got to sell these pens. So when I sell things, the money that I bring in is called revenue or income. So the money that I bring in is how I'm selling these pens. So what do you want to sell them for? If it cost me $1 per pen plus $200 setup fee, what would be a good price to sell that pen for so I can start making money? I need to sell it for more than $1. Right? And in most cases, you get a nice pen that costs you $1 to produce it. You probably want to sell it for about $3 or $4. So I'm going to sell this pen for $3 per pen. So 3 times 1, I make $3. Have I started making money if I sell 0 pens? No, I've got nothing. I'm in the debt. I'm in hole. I'm below the cost. Then if I sell 1 pen, that's $3. 2 pens would be 6, 9, 12, 15, up until I get to this point right here, where these costs and this revenue crosses. At that point, I'm losing money before that point, and then until I get to that point, I owe no money but making no money. So if I owe no money and I'm not making any money, that's the point where I break even. And then if I sell more than that number of pens, which wherever that is, what does it look like to you? I don't know. Whatever it's counting by. 1, 2, 3, 4, 5. It could be counting by 10, 20, 30, 40, 50, 60. Maybe after 60 pens, I start making money. No, I don't make money, but I don't lose money. But any point after that is where my revenue is higher than my costs. Right? Do y'all agree that this line now is above this line? So I start making money here. Do you understand? So to the right of a break-even point is where I make money. To the left of a break-even point is where I'm losing money. Do you understand? So do y'all want to know really what the break-even point is? How many pens would you have to sell to start making money in this problem? Well, let's solve it. So to solve it, when is my cost equal to my revenue? That's my break-even point. When the cost is equal to the revenue is a break-even point. Where they are equivalent. Where this line is equivalent to this line. So all I do is write down my cost function, which is what? P plus 200. When is it equal to the amount of money that I'm selling the pens for? So I'm solving this by what method? Substitution. Or I can solve it by graphing, but I don't have enough information to graph it, right? I'm just making up a problem. So when are these equal? Can y'all tell me? Solve it for P. How many pens would you have to sell for the cost to be equal to the revenue? We'll subtract P. So I get P minus P, which is 0, plus 200 would be 200 is equal to 3P minus 1P is 2P. Divided by 2, divided by 2. So how many pens do I have to sell? 200 divided by 2 would be 100. If I make 100 pens, what's my cost? Can y'all do that? 100 plus 200 is 300. And if I input 100 pens here, 3 times 100, I've just brought in $300. So you see how my cost is equal to my revenue? So if I sell 100 pens, I make $300. So this break-even point is really at 100 what? 300. That's when they're equal. I don't start making money till after that break-even point. Do y'all follow break-even points? So let's use a break-even point to solve this next problem. And you can solve it by graphing or by substitution, either one. I think that's the two easiest. So here's the first problem. A fashion designer makes and sells hats. Use the graph to estimate how many hats the designer must sell to break even. Let's see, where is that point? Y'all want to guess? Where's the break-even point? Looks like it's about what? A little bit below 100? What do y'all think? Let's estimate it. Hurry, y'all tell me. Somebody tell me where you think it could be. How many of these hats would I have to sell for my income or my revenue to be equal to my cost? Looks like it's about 98. And I'd make how much money? A little bit above 1,200, which would be about what? 1210 maybe? 1220? I don't know. Right? So this is a big question mark. How do I find the exact answer if you want to do it by graphing? You want to do it by graphing? Okay, come up with a function rule. How much do these hats... All right, so there's my hat, right? How much do these hats cost? So what are my costs? Look, that's this one. This is my expenses. Same thing as costs. So what are my expenses? It's equal to, what's my initial cost? Can y'all tell that? Where does this cross the y-axis? At what point? 0, 700. That's a y-intercept. When you write an equation in terms of y and x, x is the hats, y is the income. Instead of saying expenses, couldn't I say my costs? Y is my cost, is equal to my initial cost in slope-intercept form. That's my y-intercept, is it not? So that's my y-intercept. 700 plus the slope. What's the slope? Well, if I'm from this point to this point, what's my rise over my run? I can just subtract this. I rose up 100, 200, 300. Oh, but that's a little bit below that. So how do I find out my slope? Find my change in y over change in x. So to find the slope of this, I just take 975 minus 700 and put that over. From 0, I'm going to the right. 10, 20, 30, 40, 50. So my rise would be same thing as if I took my y minus my y sub 1, 50 minus 0. Okay, which would be 50. So I ran to the right 50, but how much did I go up? What's my rise? I have to subtract these. 975 minus 700, what is that? 975 minus 700? 275. So what's my slope? Well, what's 275 divided by 50? 11 halves, which is 5.5. Everybody agree? We good? All right, so what's the equation for this? We'll put that in slope-intercept form. This is my revenue, right? So this is my expenses. So this is my income. What's my income function? That would be the money that I make is equal to my y-intercept. That's 0. And then figure out the slope. Because I can put it in slope-intercept form to find that one, right? So what's my rise over my run? Well, this is at the point 0, 0. This is at the point x is 10, y is 125. So how do you find the slope? It's always the change in y over the change in x. So it'd be your y, which is 125 minus 0, all over the change in x, which is 10 minus 0. Or you could just find your rise over your run. I went up 125 to the right, what? 10. So it'd be 12.5. 12.5 x. Do y'all follow that? So what does this mean? This means that I'm selling these hats for $12.50 a piece, but it cost me how much to make them? $5.50 plus a setup fee of $700. How do you want to solve this? Y'all want to solve it by graphing? Graph those two function rules. There's my y-intercept. There's no reason to write that as what? 12.5x, right? So let's cut it on and let's graph them. So go to new document. Don't save my last one. Add the graph. What's my first one? 5.5x what? Plus 700. I don't see it because the y-intercept's way up there at the tip top. And then my other one would be, just go graph the other one. I'm selling them for $12.50 a piece. We got that? Hit enter. And I see one of them. Why don't I see the other graph? Okay, look, let me show you something. We're going to graph our graph just like theirs. I'm going to get this to look like this. Y'all know how to do this? Follow along with me and I'll show you. Change your window. See, my window now is going from negative 10 to 10, and it's going from negative 6.5 to like a positive 6.5 or something, whatever that is. How do I change that window? Here's what you do. Hit menu. Go to window zoom, which is 4. And go to number 1. We're going to change our window settings to be the same as their window settings on the paper. So hit 1. Can y'all tell me the x minimum value on this graph? Here's my x's. What's the lowest x is what that means on the graph? 0. Very good. Tab. Hit tab. What's my highest x on this graph? It's a little bit to the right of 120. So what are they counting by? 10, 20, 30. So what's a little bit to the right of 120? What's one mark to the right of 120? 130. You know what? That's your y, or that's your x maximum. All right, so what is scale? That's what you're counting by. The intervals that you're counting by. So I'm counting by each one of those little marks is 10, 20, 30, 40. So that's your scale is what you're counting by. So we're going to change that to 10. So what's my Y minimum? Here's my Y's. What's my lowest Y? 0. What's my highest Y? 1 right above 1400. And so I got to figure out, what am I counting by here? That's 100, 200, 300, 400, 500, 600, 700. Everybody good with that? So I'm counting by 100. So that highest point would be what? 1,500. And then what am I counting by there? 100. That's my scale. That's what it's asking. So we're going to make our graph look like theirs, okay? So hit Tab, and then just hit OK. Everybody caught up with me? All right, I'm going to hit OK. Does my graph look like theirs, kind of? A lot better than the other one, where I couldn't see it. Now, where's my break-even point? That's when my revenue, right now my revenue is below my costs. I'm not making money, I'm not making money, I'm not making money. Boom, finally I got to a point to where I break even, and then now what happens? I start making money. And here's my cost. You know how much money you make? That difference between this point here and this point here, that difference right there between this point and this point is called profit. That's the profit. Right now you're making no profit because you're at a loss. I'm at a loss, I'm at a loss. Boom, I broke even. Now I'm starting making money. How much money did I make? A little bit right now, but as I sell more pens, I'll make more money because that space between them gets bigger. You understand that? So where is that break-even point? So go to Menu. To find out where they cross, I analyze graph and find the intersection. Move that to the left of the intersection, hit Enter. Move it to the right, hit Enter. So where does that cross? It crosses exactly at 100 and 1250, which means what? If you sell 100 is the X, and the X is talking about what? Hats. If you sell 100 hats, you make $1,250. And it costs you $1,250. So you break even. What does that mean, you break even? You owe no money, but you make no money. I do not make money until after 100 hats. So if I sell 101 hats, I finally make money. If I sell 102 hats, I make money. If I sell less than 100 hats, though, see how I'm at 100? If I sell less than that, any of these X's down here, I don't make money. I'm owing money. Do you understand that? How do you find profit? See, we haven't even talked about that. How much profit would I make if I sold 101 hats? Well, profit is equal to your revenue minus your costs. So if I ever ask you for profit, it's just your revenue minus your costs. So I make profits after 100 hats. So let's say I sold 101 hats. How much profit did I make? Well, my profit is equal to my revenue, and that's how I'm bringing in money. So if I sell 101 hats, it'd be $12.50 times 101, right? That's what I've made. I took in $1,262.50, but what did it cost me for those 101 hats? Well, I have to plug that into the cost function. It cost me $5.50 per hat, and that was 101 hats plus the $700 setup fee. So it cost me $1,255.50. So how much money did I make? If this is what I brought in and this is what it cost me, I just subtract those two. I take the 1262.5 and subtract the 1255.5, and then I made $7. I made $7 profit. Y'all follow that? So the profit is the money that you make after you broke even. Okay, so let's do one more, and then we'll go to a different type of problem, because this is probably how you're going to use it more in the real world than anything else. A puzzle expert wrote a new Sudoku puzzle book. Use the graph to estimate how many books the puzzle expert must sell to break even. Then write and solve a system of equations to determine if your estimate is correct. Okay, so let's do that. Can y'all come up with a function rule for this? Where's my y-intercept and what's my slope? That's all we got to figure out. And this is my expenses. This is what it cost me to produce the book. So what's the cost of producing the book? We'll just say that's my cost. What's my cost equal to? Well, it's going to be a setup fee of $864, so that's my y-intercept, right? So what's the slope? What is it costing me per book? Just find the change in y over the change in x. So this is my x coordinate, this is a y coordinate, this is an x coordinate, this is a y coordinate. So to find the slope, I just find the differences of my y's, which is 1104 all over what? Or minus 864, sorry. All over the differences in my x's, which is 300 minus 0. So that's 1104 minus my 864, so that's the change in y, or my rise over my run. So it's 1104 minus 864 all over 380 minus 0. So let's do that real quick to find the slope. So let's go to calculate. 1104 minus 864 is 240 all over what? 300 minus 0 is 300. What's 240 divided by 300? 4/5. So what's my slope? 4/5 x. Do you know what that means? That means that my costs to produce this book is, what is 4 divided by 5 as a decimal? It's 80 cents per book plus an $864 setup fee. That's what it costs me. And x is the number of books, right? So x is your books sold. That's the x-axis. The cost is in dollars, right? So this is your income in dollars, or your expenses, or your costs. So I'm not charging much per book, and it cost me $864, so there's my function rule. So as I need more books, the cost is going to steadily increase. And so what am I selling the books for? What's my revenue function? See, this is my cost function. My revenue, or the income that I'm bringing in. Another word for that is revenue. What would my revenue function be? Well, the money that I bring in, my income or my revenue, would be equal to what? Well, look, use those 2 points to come up with a function rule, if that's too hard. Look, your calculator will do that. Watch. If you need your calculator to come up with a function rule if you're given 2 points, all you got to do is plug it in. Go to New Document. If that's too hard, in other words, to come up with a function rule in slope-intercept form, I'm going to show you how your calculator will do it for you. You just go to New Document, add Lists and Spreadsheets, and then enter those 2 points in. But I need to have an x and a y coordinate. So go up here. That's my x. You got to title your columns to be an x column and a y column. And so x is what? 0. Y is 0. So there's my first point. Here's my second point. X is 100. Y is what? 200. If you want to come up with a function rule now that you have 2 points, you go to an empty cell, hit Menu, Statistics, Stat Calculations, and do a what? Linear regression in slope-intercept form. 3. X is X. Y is Y. Did you guys do this in the other problems? You didn't have to. You could find the slope and the y-intercept. It's probably faster to do the slope and the y-intercept. But if you don't know how to do that, I just showed you a way of cheating on the EOC, right? That you can get that. And just go to OK. There it is. My slope, my y-intercept. The slope of this is what? 2. This crosses the y-axis at 0, so what's my function rule? My revenue, or y, is equal to the slope times x plus my y-intercept, which is 0. Which means what? What does this mean? I'm charging $2 per what? Book. And it's costing me 80 cents per book. So this slope is steeper. And eventually it's going to cross right there. Okay? Where is that break-even point? How many books do you have to sell? Well, it looks like to me it's somewhere around 700, a little bit bigger than 700, and a little bit bigger than 1,400. How do I find exactly where that is? What method are we going to use to solve this system of equations to figure out when my revenue is equal to my cost? When these two lines are the same, where they share the same point. What do y'all want to do? Y'all tell me. Graph it? Okay. It's already graphed for you. This equation is already graphed for you. So look, go to Control, add a page. Go to add the graph. It's already there. I don't see it. Well, that's because it's not showing it to you. It's saying, what's the function for the second one? Because the first one's already done. You just go up, and there it is. It's 2x plus 0. 2x plus 0, or just 2x. It's already graphed for you. Hit enter. And it will show you the picture of that graph. There it is. So how do I graph this one? You have to hit tab. Y equals, or C of X, or C equals, same thing as my output, my Y, because the Y is talking about the cost or the income. So Y is equal to, just type in 0.8X plus 864, and I see them both, don't I? Do you see both graphs? I put it in there, right, Tab? I put it in there, and it's got a little check mark on it. It should be on there. Why don't I see it? Yeah, my window is not the same as this window. Y'all want to make this window the same so we can see it? Let's make it look like this as much as we can. So let's change our window again. So this is helpful for the EOC for you guys. So how do I change that window? Go to Menu, Window, Window Settings, which is 1. And then my X minimum is 0. My X maximum, let's just go to, looks like it's at 800. Let's just go 800. What are they counting by? That's my scale. 50, 100, 150, 200, 250, 300. So each little mark is counting by what? 50s? And then let's go to our smallest Y on the graph. What's our smallest Y on the graph? It's 0. What's my biggest Y?
1600.
Maybe a little bit above 1600.
1700.
Okay, let's just go 1700. It's fine. Tab, and let's count by, what do they count by? 1, 2, 300, 400, 500, 600, 700. They count by hundreds, so that's my scale. Oop, what did I mess up with? My Y min is 0, sorry. And then I'm counting by what? 6. I'm going up to 1600, 1700 what we said. And then we're counting by what? 100s? Sorry, there we go. You got your numbers plugged in? Same as mine? So my lowest Y is 0, my highest Y is 1700, a little bit above that, and I'm counting by hundreds. So that would be 100, 200. That's what scale means. And just hit enter. Pretty close. Find the intersection. So to find the intersection, I go to Menu, Analyze Graph to see where they cross. Go to number 4. Move it to the left, move it to the right, and there it is. So what's my answer to this problem? 720, 1440. Remember, that is X and that is Y. What does X refer to in the problem? Books. What is Y referring to in the problem? Money. So what does this mean? This means if I sell 720 what? Books, I break even. What does break even mean? You make no money, but you lose no money. So, how many books, and this will be a question on the homework tonight, how many books must you sell to make money?
Oh, 721.
One more than that, so 721. Okay? So you better sell 721 books to make money. If you sell 719, did you make money?
No.
If you sold 720, did you make money?
No.
You made no money, but it cost you no money either. So that's what break even means. You make no money, but you sell no money. So that intersection is at 720 what? 1440. So I have to spend $1,440, and I better sell 720 books to make that money back. If you do not plan on selling 720 books, you better not go into business. Okay? Because you will lose money the whole time. Make sense? So you think you can sell 720 books? If so, do it. If not, you better not produce it. All right, here comes another question too. Let's just see if we can set up this system. Now, this is another one I would solve by graphing. So y'all ready? Here's what we got. At a local zoo, 2 water tanks are being filled up with water. Okay, when will the 2 tanks have the same amount of water? So here's the first tank. I don't know if you can see it. It's talking about this one. In this tank, it has 50 gallons in it right now. And you're adding water to it. So you're putting water inside the tank with a water hose. So there's a water hose here and water's going inside the tank. Okay? You get the idea? So I don't know where that's going. It's over here to some sort of faucet or whatever. So anyways, you're filling that up. You get the idea? Okay, so how fast is that going in there? It's going in at a rate of 10 gallons per hour. So what is a function rule for this? What's an equation that models that? Well, the amount of water that's in the tank is equal to what? The 50 that's currently there plus the rate at which it's filling up, which is the slope. You're adding 10 gallons per what? Hour, which is x in this case. So we're going to let x be equal to the number of hours and y is the number of gallons. You follow? Okay. So that would be 10x plus the 50. Now, you got this other water tank here. And it says that this one has 29 gallons in it. And it's been filled up. I don't know if you can see, there's the water hose there. It's been filled up at a rate of 3 gallons per hour. So the amount of water that's in this second tank, see this is tank 1 and this is tank 2. The amount of water that's in that second tank is equal to 3 gallons per hour because it's been filled up 3 gallons per each hour. So for 1 hour it's 3 gallons, 2 hours 6, 3 is 9 and so forth. Plus the water that's already in it, which was what? 29 gallons already in it. So this is the beginning amount. This is the beginning amount. This is a rate at which it's being filled. This is a rate at which it's being filled. When would they be the same? Let's draw a graph of this. Here's my y-axis. Here's my x-axis. The x-axis is talking about the hours that you're running the water hose. The y-axis is talking about the amount of water that's in each tank. The first tank started off at what? 50 gallons. Let's say that's 10, 20, 30, 40, 50 gallons. And it's being filled up at a fast rate of 10 gallons per each hour. So 10 gallons per hour, up 10 gallons per hour, up 10 gallons per hour, up 10 gallons per hour. So here's hour 1, hour 2, hour 3, and so forth. So it's been filled up right here like this. All right, here's my other one. How many gallons of water was in this tank to start with? 29. So that's 10, 20, 30, 40, 50. So it starts off at 29, which is about right in here somewhere. See that okay? So that's about right there. And then it's been filled up a rate of 3 gallons per what? Hour. So it's not going up as fast. So 3 gallons per 1 hour would be about right here. 3 gallons per 1 hour would be about right here. So it's been filled up slower. When would they ever cross? When are the tanks ever the same amount? Never. Right? There's no way. Because if I extended this line out, look, it's going up really fast. This one's going up really slow. It's like saying this guy's running a race that's really, really fast and he gets a head start. And this slower guy doesn't get a head start and he's jogging while this one's sprinting. Is the jogger ever going to catch up with the sprinter if the sprinter got a head start? No. Okay, so the tilt of this is really steep. The tilt of this is really flat. The only place that they would cross would be where? Over here somewhere to the left, which is in negative time, which that doesn't make sense. So we only look at quadrant 1 when we graph positive things in the real world. So the answer is never. Why? Because the tank with the most water is being filled at a faster what? Rate. There's no way the other one's going to catch it if it's being filled at a faster rate. So it's never because the tank with the most water is being filled at a faster rate. Y'all got that? All right, we'll look at one more like that. So let's look at this next problem. Let's see if we can draw a picture of this one too. The zoo from problem 2 has 2 other water tanks that are leaking. So I got this water tank here, and I got another water tank here. So we'll call this one tank 1 and this one tank 2. There's a hole in it, and water's leaking out of that hole. There's a hole in this one, and it's leaking out and forming a puddle. You follow? One tank contains 10 gallons of water, so this one has 10 gallons, and the water is coming out of it at a rate of 2 gallons per hour. Follow? This one has how many gallons in it? The second one contains 6 gallons of water, so it has less, and it's leaking at a rate, so the water's coming out at 4 gallons per hour at a faster rate. When will the 2 tanks have the same amount of water? Well, let's come up with a function rule for this one. The amount of water, which is y in this one, that's what we're going to be talking about is y. This is the water amount, which is my y-axis. And then the x-axis, which is here, is going to be the time. So we're going to say y, which is the amount of water in the tank, is equal to how many gallons were in the tank? 10. So this is the water in gallons. And it's leaking or coming out at a rate of 2 gallons per hour, and the hour is my time, which is my x-axis. That's why I'm using x there. So there's equation 1. Let's graph it. All right, so let's say this is 2, 4, 6, 8, 10, 12, right? So we're counting by 2s. 4, 2. And so my beginning amount is 10. And then it's leaking at a rate of 2 gallons, so that's 2 gallons per hour. 2 gallons per hour, 2 gallons per hour, 2 gallons per hour, 2 gallons per hour, until it's empty. It'll be empty right there, right? Everybody follow that? Now the next one, the amount of water in this tank starts at 6, and it's leaking at a rate of 4 gallons per hour. So it's beginning here, and then it's going down to 4 per every 1 hour. 2, 4 per every 1 hour, so it would be empty about right there. Because it's leaking at a faster rate. So this one's sharper. It's going down faster, twice the speed of this one. So it gets empty here, gets empty here. So when are they ever going to have the same amount of water? Never. Never. Okay, so the tanks will never have the same amount. Because why?
Because one goes faster than
The one with the least amount is leaking at a faster rate. So the one with the least amount is leaking at a faster rate, so it's going to empty faster than the one that has the most amount, so they'll never intersect. So you can just say, hey, they'll never intersect because the slopes are too steep on the one with the least amount. Y'all good with that? That makes sense, right? So don't think that you look at an answer and go, hey, this ain't never going to happen. Well, that's the way the real world happens. Sometimes things don't happen. Now, this next problem, I need to explain something to you. All right, I'm not a very good artist, but you get the idea, hopefully, with what I'm going to do here. What does that look like to you? All right, so that's what it was supposed to be. It's an airplane. So we have something called airspeed. So that's when you put the throttle down at 500 miles per hour, let's say. So my airspeed is 500 miles per hour. But sometimes we get a push from wind. So this right here is wind that's blowing at my back. That's called a tailwind because it's pushing me. This is called a tailwind. Let's say that tailwind assists my speed by 5 miles per hour. this would be equal to my ground speed. So if I have a wind speed that's assisting me, it's adding to my current airspeed to get my ground speed. So if I have a 5-mile-an-hour tailwind going at 500 miles an hour, it's going to push me and make me go faster for a total speed of what? 505 miles per hour. Right? It's kind of like sitting in a boat in a pond. When you sit in a boat in a pond and the wind blows, what happens to you? You're being pushed without having to do anything. So the wind is going to push the airplane. Now, sometimes it doesn't work that way. Okay? Sometimes it works against it. So I'm going to try to draw that same airplane. Right? Doesn't look very good. But sometimes the wind blows in your face. That's called a headwind. Okay, so it's going to push the airplane down. So if the airplane speed, so the airspeed now is 500 miles per hour, and the wind speed, this is my wind speed, is 5 miles per hour, this time it pushes against you. So to get my total speed, which is known as my ground speed, I would take my airspeed minus the wind speed to get my ground speed. So if my airspeed is 500 miles per hour and my wind speed is 5 miles per hour, how fast am I going now? Slower. Right? So both airplanes were supposed to be going 500 miles per hour if there was no wind. So that's what airspeed is. If there's no wind, it's going 500 miles per hour. This one's going 500 miles per hour. But if the wind is pushing you, it's going to assist you to go faster of 500 miles per hour if the wind speed is 5. But if the wind speed is 5 miles per hour and it's in your face, it's going to make you go slower by 5 miles per hour. You understand? That's what this next problem is talking about. In this next problem, I'm going from Los Angeles, California to North Carolina. And the wind is blowing this way. Okay, so my ground speed with the wind assisting me is 550 miles per hour. So to get my 550 miles per hour, it is my airspeed plus my wind speed. At the same time, an airplane is going in the opposite direction at the exact same time, exact same distance. And its ground speed is 495 miles per hour. But the wind's blowing in its face, so it's going to go slower. So that would be its airspeed minus the wind speed in its face. Can y'all tell me what the airspeed is and what the wind speed is of these airplanes? Not the total ground speed, but the total speed of the air and the wind. So how fast is the wind blowing, in other words? Well, to figure this out, I would not use graphing. I would not use substitution. I would use elimination and add the two together. If I add these two together, what do I get? 5, 4, 6. 1,045 is equal to A plus A is 2A. What's a W minus W? If you were to add those together, 1, a positive 1, and a negative 1 is 0. So divided by 2, what's my airspeed? It's 1045 divided by 2. So I just take 1,045 divided by 2. Control Enter. Be 522.5 miles per hour. So that's how fast my airspeed is. My airspeed is blank. 522.5. Now what's the wind speed? Can anybody tell me what the wind speed is? Just plug it in. 522.5 plus what is equal to 550. Just plug it into equation 1. And to solve equation 1, you just subtract 522.5 minus 550. So take 550 minus the 522.5, and I get 27.5 miles per hour. Miles per hour. So when I add those two together, I should get 550. When I subtract those two, what should I get? 495. Let's see if I do that. 422.5 minus 27.5. It should give me 495. We did it right. That's the same way as this next problem if I'm rowing a boat. If I'm rowing a boat against the current, it pushes me. With the current, it pushes against me, which makes me slower. With the current will push you and make you go faster, right? That's what this next problem's talking about. Your current upstream is 2 miles per hour. Your speed going upstream is 2 miles per hour. You travel the same distance downstream, which means the current is pushing you downstream, so you get to go faster. What would your rowing speed be? See, in order to row a boat, you take your rowing speed plus the current. And that will make you faster, doesn't it? If I'm row at a steady pace every single time. All right, what's my speed of rowing if there was no current? I don't know. What's the current speed? I don't know. But I do know that my rowing downstream is 5 miles per hour, which is going to make me go faster. So the downstream means I'm going with the current. So I'm going this way in my rowboat, and the current is pushing me this way, which is causing me to go faster. Do y'all follow that? Now, against the current, like if the current's pushing me from this way, and if I don't row, what's going to happen if the current's pushing me from the wall back to this wall? If I'm not rowing, what's going to happen? I'm going to be pushed backwards. So my speed there is my rowing speed minus the current would be equal to the speed at which I'm going upstream, which is 2 miles per hour. Solve that to tell me what your rowing speed is and what the current is. How would you solve it? Adam. 2r plus 0 is equal to, what's 5 plus 2? 7. Divide by 2, divide by 2. So what's 7 divided by 2? 3.5. So my rowing speed is 3.5 what? Miles per hour. What's the current? 3.5 plus what is going to give me 5? 3.5 plus blank is equal to 5. That's my current speed, which would be, come on. There you go. You got it? So that's my rowing speed and my current. Let's do one more like that. Suppose your rowing speed in still water is 3 miles per hour and the speed in the current is 4 miles per hour. What happens when you try to row upstream? Okay, so here's what we got. We're in a boat. Right? My rowing speed, so here's my paddles in the water, right? And here you are rowing. I'm rowing this way at 3 miles per hour. There's a current in the water that's pushing me against me going this way at 4 miles per hour. Answer the question. What happens when you try to row upstream if the current's pushing you this way at 4 miles per hour and you're rowing at 3 miles per hour? You're going backwards. At a rate of what? Alright, let's see if we can finish this last one then. Alright, so here's the last one. And we'll be done with the notes. A kayaker paddles upstream for 1.5 hours. Okay? And then he turns around and goes downstream, and it takes him 1 hour. He travels 3 miles each way. So this distance from here to here is where he's going. He's going here, and then he's going here. Upstream and downstream. This distance is 3 miles. Going downstream, it took him 1 hour. What's his speed? Speed is distance over time. He went 3 miles in what? 1 hour. That is 3 miles per hour. Well, this one took him 1.5 hours to go 3 miles. What's his speed there? Distance divided by time. 3 divided by 1.5 would be 2 miles per hour. Isn't it? Let's see if that's right before we go. 3 divided by 1.5 is 2. Look. What's the river's current? Look, if I went 2 miles per hour and 3 miles per hour, that would be the rowing speed minus the current is equal to my 2 miles per hour. The rowing speed plus the current is equal to my 3 miles per hour. Add these two together and I know my rowing speed. What would my rowing speed be? 2r is equal to 5. Divide by 2. Divide by 2. My rowing speed would be 2.5 miles per hour. But it didn't ask for the rowing speed. It asked for the current. What would the current be? 2.5 minus what is equal to 2? Can y'all tell me? There you go. It's A. All right, that's it for your notes today.